Here, in the sun-drenched landscape of California, stands a structure seemingly from the future. It is a perfect circle of glass and steel, a modern-day temple dedicated to imagination. This is Apple Park, the heart of a global technological ecosystem. Within these curved walls, a process begins. It is not with the clamor of machinery, but with the quiet hum of human thought. Teams of designers, engineers, and visionaries gather. They sketch, they debate, they dream. They are searching for the next evolution, the next shape, the next experience that will connect us all. An idea for a new iPhone is born not as a product but as a feeling, a seamless extension of our own senses and intentions. The journey starts with a simple line drawn on a digital tablet. This line becomes a curve, a contour, the potential edge of a device that will one day rest in millions of hands. Countless iterations are explored. Materials are considered not just for their strength but for their touch, their warmth, their interaction with light. Every millimeter is scrutinized, every angle debated with a profound sense of purpose. The goal is a kind of perfection, an object so intuitive that it feels less like a tool and more like a companion. And so the blueprint is finalized. A digital file containing thousands of hours of human ingenuity is ready. From this single point of origin in Cupertino, a signal radiates outward, calling upon the resources of the entire planet. The quiet act of creation is complete. Now the epic journey of manufacturing is about to begin. The story of this device now leaves the pristine labs of California and travels to the wild, rugged corners of our planet. For an iPhone to be born, the Earth itself must first offer its treasures. Deep within the mountains and plains lie the fundamental ingredients. In vast open-pit mines in Australia and Chile, colossal machines excavate the ground, seeking the soft, silvery white metal known as lithium. This remarkable element holds the key to power. Its extraction is a monumental effort, a resource now as precious as gold. Elsewhere, the search continues. From the red earth of Guinea or the bauxite-rich landscapes of Australia, another crucial element is unearthed: aluminum. This lightweight yet durable metal will form the elegant and resilient chassis of the phone. The raw ore, a simple reddish-brown rock, bears little resemblance to the sleek frame it will become. At the same time, in mines scattered from South Africa to Peru, miners search for glittering veins of gold, not for jewelry, but for its unparalleled ability to conduct electricity, ensuring the vital messages within the device flow without fault. The heart of the iPhone, its intelligence, requires a substance born from common sand: silicon. In quarries around the world, quartzite is mined, the raw form of this essential element. This humble material, the second most abundant in the Earth's crust, holds the potential for incredible complexity. And alongside it, a collection of lesser-known but equally vital materials are sought. These are the rare earth elements with names like neodymium and dysprosium, mined predominantly in China. These raw, untamed substances are now loaded onto immense cargo ships and transport trucks, beginning the next stage of their incredible journey from deep within the Earth to the palm of a human hand. The raw materials wrested from the Earth now arrive at colossal industrial facilities. This is where the magic of transformation truly begins, a modern form of alchemy. The reddish bauxite ore, for instance, embarks on a fiery journey. It is crushed, washed, and dissolved in a caustic solution under immense pressure and heat. This process, known as the Bayer process, separates the aluminum oxide from the rock. This fine white powder is then sent to smelters. In the smelters, an enormous electrical current, enough to power a small town, is passed through it. The intense energy breaks the chemical bonds, and a silvery liquid emerges: pure, molten aluminum, the stuff of a future iPhone body. Meanwhile, the humble quartzite rock undergoes its own metamorphosis. It is heated in a furnace with carbon, to over 2,000 degrees Celsius, a process that purifies it into metallurgical-grade silicon. But for the heart of an iPhone, this is not nearly pure enough. The silicon is further refined through a series of chemical processes, until it reaches an almost unbelievable level of purity, 99.9999999% pure. This ultra-pure silicon is then melted and slowly drawn into massive, perfect, single-crystal cylinders. These cylinders, gleaming like polished obsidian, are the building blocks of digital intelligence, each one a perfect, ordered structure grown in a lab. In specialized glass factories, a different kind of alchemy is at play. Sand, sodium carbonate, limestone. They are mixed and melted in a furnace. But to create the famously durable screen of an iPhone, something special must happen. The glass sheets are submerged in a hot bath of potassium salt. In this ion exchange process, smaller sodium ions in the glass are replaced by larger potassium ions. This crowds the surface of the glass, creating a layer of compressed stress. Each material follows its own unique path of refinement. The raw stuff of the planet has been tamed, purified, and prepared for the next great step. The refined materials, now in their pure and usable forms, are dispatched to yet another set of destinations. These are the workshops of the world's most advanced component manufacturers, a global orchestra of specialists, each a master of their craft. The silicon cylinders arrive in Taiwan, at the headquarters of a company named TSMC. Here, in some of the cleanest rooms on Earth, thousands of times cleaner than a surgical operating theater, a technician in a full cleanroom suit inspects a large, circular silicon wafer covered in microchips. The silicon is sliced into paper-thin discs known as wafers. Upon these wafers, a process of almost unimaginable precision unfolds. Using light, chemicals, and layer upon layer of microscopic materials, billions of transistors are etched onto each wafer, forming the intricate neural networks of the A-series chip, the iPhone's brain. While the brain is being forged, the eyes and the face are being created elsewhere. In South Korea, giants like Samsung and LG receive the specialized glass and rare earth elements. They use a process called vapor deposition to layer organic light-emitting diodes, OLEDs, onto the glass. Each tiny pixel is a world unto itself, capable of producing its own light and color, creating the vibrant, high-contrast displays that will become the user's window into the digital realm. At the same time, in Japan, another master of its craft, Sony, is at work. They are assembling the camera modules, layering microscopic lenses and exquisitely sensitive sensors designed to capture light and turn it into lasting memories with astonishing clarity. The device's heartbeat, its source of life, comes from yet another corner of the global workshop. Companies in China and South Korea like ATL and Samsung SDI take the refined lithium and other materials and begin the delicate process of constructing the battery. They layer sheets of anode, cathode, and separator material, rolling them into a compact, energy-dense package. This is a task that requires immense precision, as the battery must be both powerful and safe, capable of storing and delivering energy reliably day after day. Each of these components represents the pinnacle of its respective field. It is a global symphony of creation, with each section of the orchestra playing its part to perfection. All roads now lead to China, specifically to vast industrial complexes that defy the imagination. The largest and most famous of these is operated by Foxconn in cities like Zhengzhou, a place often called iPhone City. Here, a city within a city exists, a sprawling ecosystem built for a single purpose, the assembly of the final device. Into this hub flow the components from all over the world, the processors from Taiwan, the screens from South Korea, the cameras from Japan, the batteries from other Chinese provinces, and countless other parts arrive by the truckload, day and night. It is a logistical ballet of breathtaking scale and precision. The scale of this operation is difficult to comprehend. These factories are not merely buildings, they are self-contained worlds. They employ hundreds of thousands of people, with their own dormitories, cafeterias, and recreational facilities. The workforce is a river of humanity, flowing in and out of the factory gates in meticulously organized shifts. The arrival of a new iPhone model transforms the entire region, as the factory ramps up production to meet a global deadline. The air itself seems to hum with a sense of anticipation and immense industrial power, a concentration of human effort unlike almost anywhere else on Earth. Inside the factory walls, a world of extraordinary organization unfolds. The millions of individual components are received, cataloged, and stored in a labyrinthine warehouse system. Automated guided vehicles zip along designated pathways, delivering trays of screens, processors, and casings to their assigned assembly lines. Every single component is tracked with a digital precision that mirrors the complexity of the device itself. The assembly lines themselves are wonders of human-machine collaboration. The process flows like a river, with the bare chassis of an iPhone entering at one end. The dance begins. The first step is to give the iPhone its form. A machine guided by the digital blueprint takes a solid block of refined aluminum and mills it with diamond-tipped cutters. Shavings of metal fly away as the machine carves out the precise unibody enclosure, creating the smooth curves and exact openings for buttons and ports. This perfectly sculpted frame then arrives at the start of the assembly line. Here the first human hands guide it into place, ready to receive its soul. The first component to be installed is the most important, the logic board, with the A-series chip, the brain, already mounted upon it. It is gently snapped into place, a moment of profound significance. Next comes the installation of the many organs that give the device its senses and its life. A worker carefully places the taptic engine, the small motor that will provide haptic feedback. Another delicately fits the intricate camera module into its housing, its lens a tiny, perfect eye looking out at the world. The battery, the device's heart, is carefully secured with special adhesive strips, ensuring it stays firmly in place. Tiny, flexible ribbon cables, the nervous system of the phone, are meticulously connected by hand and with tweezers, linking the processor, linking the screen, linking the cameras, linking the charging port. Each connection is a critical link in a complex chain. The moment of illumination is next. The brilliant OLED display, a fragile and expensive component, is brought to the line. A robotic arm applies a precise bead of waterproof adhesive around the edge of the frame. A worker then carefully aligns the screen, connecting its delicate ribbon cables to the logic board, before pressing it firmly into place. The iPhone is now whole, its window to the world sealed shut. It is then placed into a special press that applies uniform pressure, ensuring a perfect, water-resistant seal. For the first time, the device looks like the object of desire conceived in Cupertino, but it is still an empty vessel. The final step in its birth is to give it a consciousness. The phones are placed in racks and connected to a network. Here the iOS operating system, the software that defines the entire user experience, is installed. With a flash of data, the device comes to life. The iconic Apple logo appears on the screen for the very first time, a sign that the hardware and software are now one. The intricate dance of assembly is complete. What was once a collection of disparate parts from around the world is now a single, functional, and powerful piece of technology, ready for the final tests of its young life. Before an iPhone can be sent out into the world, it must prove its resilience. A rigorous series of tests begins. Randomly selected units are taken to quality control labs. Here they face a gauntlet of challenges. A machine hoists a phone and drops it from various heights: concrete, tile, carpet, testing the strength of its frame and glass. Another machine repeatedly presses the buttons thousands of times. The screen is subjected to automated touch tests. Jets of water spray the device to confirm water resistance. Only by surviving these trials can the batch be approved. Final packaging begins. Final polish. Protective film applied, placed into the iconic white box. Charging cable, small information packet, box sealed and shrink-wrapped, boxes packed into larger cartons, cartons stacked onto pallets, forklifts load pallets onto trucks, trucks drive to nearby airports, cargo planes are loaded and take off, and then, they are everywhere. A photographer capturing a sunset, a student studying in a library, a family video calling relatives across an ocean, born of the earth and forged by a global network of human ingenuity, to connect, to create, to inform, a seamless part of modern life. But the story does not end here. Years later, devices reach the end of their life and begin a new journey. Daisy the robot carefully disassembles devices, screw by screw, aluminum, gold, rare earth elements. The iPhone has changed dramatically over time. The original model, today's powerful devices, brighter screens, faster processors, more capable cameras. The fundamental idea remains the same. A simple, beautiful, and powerful tool that empowers people, from a thought in California, to the minds of the world, through the forges of industry, into the hands of assemblers. A testament to imagination, collaboration, and a relentless pursuit of perfection. A story of technology and of humanity.